Very good morning, dear students of class 10. Today I will explain about another video of class 10 science chapter number 4, right? In this video, I will explain mainly about the atomic number, atomic mass and electronic configuration, right? Before I start explaining this video, please take out your notebook, pen and pencil to copy down the important portion, right? Shall I start? Yes. Now, before I start explaining this atomic number, yesterday I already explained about the three subatomic units, right? What are they? They are proton, electron, and neutron. Right? Proton is what? Proton is known as the positively charged particle. Electron is what? Negatively charged particle, but in here no charge. We already studied these three subatomic particles of an atom, right? Now, these three subatomic units, they are all present inside the atom, right? Now, we also know that the number of protons is always equal to number of electron. Right? The number of proton is always equal to number of electron. Right? Now, this is the most important part, okay? This is the foundations of the atomic number and the atomic mass. Right? Okay? Now, look here, I will start explaining about the atomic number. What is the atomic number? Right, atomic number is denoted by capital letter Z. Don't forget, atomic number is denoted by the capital letter Z. What is the atomic number? The number of the protons present in, or the number of the proton, okay, the number of the protons in one atom, of an element, okay, is called atomic number of that element. Right. The number of the protons in one element, or in one atom of an element, is called atomic number of that element. Right. Look here. Please give this what point, okay? The main important point, okay? Don't forget the main important point, right? Or I can write this definition like this, okay? You can write this definition like this, that is, or in place of this what proton, you can write the number of the electrons. It's protons, electrons in one atom of an element is called atomic number of that element. Why I am writing this one in place of the proton? Why I am writing this one electron? Because we all know that the number of the proton is always equal to number of the electron in an atom, right? Because of that, in place of the proton, I am writing this one electron. Okay? Any confusion? No. And this one, this lesson, okay? Now, from these two definitions, we can understand that this atomic number is equal to number of proton, right? The proton we can note by P, or this atomic number is also equal to the atomic number is also equal to the number of electron. Then we can write like this. This Z is what? Atomic number is equal to number of the proton is equal to number of electron. P stands for proton, E stands for electron, Z stands for atomic number. I will write in here where Z is equal to atomic number, P is equal to proton, E is equal to electron. Right? This is the most important. Okay, that's why this definition. Okay, you need to understand this definition, right? And I also told that in an atom there are three subatomic particles: proton, electron, and a neutron. Okay, the number of the protons should be always equal to the number of the electron, right? And then in this definition, I'm explaining that the atomic number is nothing that is the what? The number of the protons, right? And same thing, we can write the number of the electron also. Why? Because number of the proton is always equal to the number of the electron. Let's copy down. Done? Okay. Next, I will explain about the mass number or atomic mass. Okay, mass number, or we also write that atomic number, atomic mass, not atomic number, atomic mass, and it is always noted by capital letter A. This is the O. What is the mass number or atomic mass? Right. The total number of protons and neutrons in one atom of an element is called mass number, or we can write is atomic mass of that element. Now look here, the total number of the proton, right? The total number of the proton and the neutron in one atom of the element. Look here, there is the total number in the, I mentioned in here, there is the sum of the, right? The sum of the proton and the electron, neutron in one atom of an element is called mass number, right? Now here, in place of this word proton, I will write here the total number of electron and neutron in one atom of an element is called mass number, or we can write as atomic mass of that element. Okay, in here the atomic mass or the mass number is denoted by, it is denoted by capital letter A. Okay, then I write in this order. Okay, then what? This A is equal to P plus N, or we can write like this: A is equal to E plus N. Where A is equal to mass number, okay, P is equal to proton, N is equal to neutron, and E is equal to electron. Right. In here, don't forget P and E is equal. Right. Understanding? That's why in place of the P, I write in E in here. Okay. Please copy down this one. Done? Okay, yes. Now, next, I will explain about the relationship between mass number and the atomic number. Right, the relationship between mass number and the atomic number. Mass number means atomic mass, right? Now I will explain about the relationship between mass number. It means atomic mass and atomic number. Look here, we all know that atomic mass A is equal to P plus N, right? Look here, A is equal to Z plus N, where P is equal to Z. We all know that number of proton is always equal to number of the atomic number, the electron and the atomic number, right? Or we can also write like this: Z is equal to A minus of N. Right. Look here, I will mention in here where A is equal to mass number, Z is equal to atomic number, P is equal to proton, N is equal to neutron. Right. Or in here I will write this one: A is equal to E plus N. E is equal to electron. Okay, let's copy down this one. Done? Finish? Okay. Now next is what? Electronic configuration. Okay? Electronic configuration. What is meant by electronic configuration? That is, according to the Niels Bohr, he told that electrons are located or exist in their respective cells, okay, in a definite number, okay, in a fixed number. It cannot be changed in this fixed number, right? Now, look here, electronic configuration. Electronic configuration. Now, look here, electronic configuration is what? That is the distribution of electrons okay, in their respective cell is called electronic configuration. That is the distribution. How many electrons will be present in this first cell, second cell, third cell, fourth cell. This type of distributions of the electron in their respective cell is known as the electronic configuration. Right? Now look here, the formula. How to distribute the electron according to this formula. The formula of electronic configuration. The another name of the electronic configuration is known as the, or we can write it, distribution of electrons, okay, is 2n square, right? 2n square, where n is equal to 1, 2, 3, 1, 2, 3, 4, so on. Right? Now this one, okay, this one is nothing, that is the first cell. First cell, okay? First cell, or we also known as the energy level, okay? That we indicate by the K. 2 is the second cell energy level, L. 3 is the third cell energy level, M. 4 is the fourth cell energy level, M. Okay? Let's copy down this one. Then, okay. Now look here, I will draw the structure of the atom. This is the nucleus, right? Outside the nucleus, this is the first cell, and this is the second cell, this is the third cell, this is the fourth cell. Right, look here, the first cell, I will write this is the K, second cell, that is the L, third cell, M, and the fourth cell, N. Sorry. Now, look here, number of electrons, okay, in first cell. Okay, now look here, the formula of electronic configuration is what? This 2n square, right? In the first cell, 2 into 1 square, where n is equal to 1. First cell means n is equal to 1. Then it becomes, this is the first cell. 2 into 1 is equal to 2. In here, the maximum number of electrons which can be present in the first cell should be not more than 2, okay? 2 or less than 2, right? And the second, this one is the second cell. This is the K, this is the L. In here, 2n square, 2 into 2 square is equal to 2 into 4 is equal to 8, where this n is equal to 2. Now look here, in here, the number of electrons can, okay, locate in this L not more than 8, okay? Till 8 it can exist up to the this L, okay? The third one, third cell, that is the M. 2n square is equal to 2 into 3 square becomes, n is equal to 3, it becomes 2 into 9 is equal to 18, not more than 18, right? Same thing in here, 4 also, in the fourth cell, that is the end, okay? in here 2n square. Look here, 2 into 4 square. Okay, in here n is equal to 4 becomes how many? 2 into 16 is equal to 32. Not more than 32 electron will be exit in the n. Okay, up to 32 they can exist in the n. Okay, let's copy down this one. The first cell 2, second cell 8, third cell 18, fourth cell 32. Right, let's copy down. Okay, next time please watch this video carefully. Okay, if you have any doubt and any confusion, let me know. Okay, and please watch this video till end. Okay, thank you and have a nice day. Bye bye.